Okay folks, just a bit of an update on where we're at with the two-wheeler self-balancing robot. I've ported across to an ESP32 platform from Arduino, so I'm now using the ESP32S3, which I have here. This is one that has a built-in camera, so for later I will be using a monocular setup for the robot, single camera here with an SD card, and I've tested that and that works very well. On the board here, so I've got my microcontroller, I've got a buck converter to take up to 30 volts in and turn that into a 5-volt rail. I've got a couple of these stepper motor drivers. These are both configured for the stepper motors that I'm using, which have a maximum coil current of, I think, 330 milliamps, thereabouts. So I've adjusted those to never exceed around 300 milliamps. And I've got a IMU here, so inertial measurement unit. It's MPU 6050, and I've configured this and I've tested it with the S3. Sorry, I've tested with Arduino. It works really well using the DMP, the onboard DMP. So that gives me sensor fusion and a bunch of stuff there, and that's working really well. I haven't ported that to S3 yet, but I will, or the ESP32. So this is the simple board layout. I'm programming everything here via VS Code on my Fedora 42 Framework 13 laptop. I'm using platform IO, which is really nice in VS Code for both Arduino and ESP32 development. It's working out really well, and I just program that. I just program that over a USB-C cable here, which you can see. So I just plug that straight into the microcontroller when I need to program it. Now, what I've done though is during the development of the board and just getting this up and running, I'm using a bench power supply. So I've got a Sigilant power supply here. I'm running everything at 12 volts and a maximum of half an amp for just protecting the circuit. I don't need anywhere near that current, so half an amp is plenty. And I'm just running that at 12 volt, half an amp or 12 volts here to my breadboard. That goes into the buck converter, converts that 12 volt rail into 5 volts. The 12 volt rail still supplies the stepper motor controller, because I still need to run the stepper motor at a higher voltage. So I'm running it at 12 volts, so it works out to be about 11. But the 5 volt rail here then feeds the microcontroller. So that goes straight into VUSB on the ESP32S3 pin, and then that I take that 3.3 volts out to, that's my logic level, to the stepper motor controller, and I'll do the same for the MPU when I get that wired up. So that's all working, and I've got a funky little LED display indicator here, which turns on when I have bench power supply to the board. So that's where we're at. The stepper motors are just these kind of funky little stepper motors. They're good quality ones, I think, or at least decent ones. They weren't super expensive, but they're working well. And as you can see, the stepper motor driver obviously is connected to the microcontroller for logic. For there's a direction pin and a step pin in terms of how you're driving the motor, and then that is connected to the motor via this mess here. Now the bit that I'm really happy with is I've just got the end-to-end Bluetooth working. So what I'm doing here is, from my sketch, I'm supporting both controlling the motor and setting up a Bluetooth or a BLE server on the microcontroller. So this little ESP microcontroller acts as a BLE server, low energy Bluetooth server, and then I can connect to that over anything that understands Bluetooth, like my phone, for example. So I'm just using NRF scanner here, and I'll show you how that works right now. So we'll just turn on the bench supply. So we're running 12 volts. That will come on. This funky little LED is on. Now I've got a bug at the moment where I need to hit the restart button before I get everything on. I need to debug that. So I've just hit restart. The system is up. Now if I scan on my phone, I should see Robot S3 turn up, which I do. So I hit connect. So I'm now connected from my phone to my microcontroller here. I've got a service. Now I haven't done a structured payload or an API or anything. If I hit forward, then I would expect F for forward. I would expect this stepper motor to turn on. So we hit forward, and we do have the stepper motor working. You can see if I hold it, it's moving. That's great. If I then send through, I don't know, stop, then the motor should stop, which it does. Okay, so that's great. If I do, let's go, I don't know, send a backwards command, so that's B. Okay, that's back on. And so the motor is going in the other direction. Okay, that's good. And then I've got a safety thing here where if I just disconnect, then the motor stops. Okay, so the motor is still active and on. There's still torque on this end, on this motor, and it's effectively locking it in place. But that's the setup so that I can control everything over BLE, and then you know, I can turn the supply off. The idea is that eventually I will have speed control and I'll be able to enable and disable the motor through the enable pin here. Right now I've just tied it to ground, and that will give me a little bit more control over the motor and mean it's not always engaged. And the next step, I suppose, is to, now that I've got the full end-to-end Bluetooth to microcontroller to stepper motor functioning properly, the next step will be to wire up the MPU 6050 to get the gyroscope measurements again, port that to run on the ESP32S3. I already have code that works there well using the DMP, like I said, on the MPU 6050. I've got that working on Arduino, so I'll do that for the S3, and then I should be in a position to start to control the robot using a simple PID loop that I've already programmed and tested a little bit anyway. Control the robot with that PID loop and start to get balancing working through the IMU. So that's where we're at.